Good day, students. How are you? Now continue our video lessons. Our topic is named the investigation of the given function for inflection point with help of the higher derivatives. Right, and it is the last, that is sixth Roman point. The investigation of the given function for increment for inflection points with help of the higher derivatives. Here, the second order critical points are found. For this, we must equalize the second derivative to 0 and then find the root of the obtained equation, and then substitute this second order critical points into the higher order derivatives. If higher order derivatives must be found until the higher order derivative isn't equal to 0. If the first non-zero derivative has the even order, that is the given second order critical point is inflection point. But is the order of the first non-zero derivative is the even number, that is our second order critical point isn't inflection point. Now mark these properties, indications. If the first non-zero derivative, the first non-zero derivative has odd order, then the given second order critical point is inflection point. As odd order, then it is inflection point. But if has even order, then no inflection point. Inflection point. No inflection point. and no infinity point. And consider the next example. Please look at the board and then solve the corresponding example. Consider next example. Find the inflection points. Inflection points of the gain function with help of the higher derivatives. Now write function f of x. 2x to 6 plus 3x to 5 minus I'm sorry. F of x is x to 6 minus 3x to 5 minus 20x to 4 plus 50x plus 40. Solution. First, we must find the second order critical points. For this, we must equalize the second derivative to 0. But for finding the second derivative, first we must find the first derivative, because the second derivative is a derivative of the first derivative. First find first derivative. F prime of x is 6x to 5 minus 15x to 4 minus 80x cubed plus 50. Then find the second order derivative, and you know that second derivative is the derivative of first derivative. F2 prime of x equals 30x to 4 minus 60x cubed minus 240x squared. Then equalize second derivative to 0, and we obtain the corresponding equation, and we must find the rules of this equation. For finding this equation, we can take 30x squared out of the parentheses. 30x squared. We have x squared in parentheses, minus 2x minus 8 is 0. And then we can define the roots of the last equation. x1 is 0, x2 is 4, and x3 is minus 2. R the second order critical point. R the second order critical points. Then find the third derivative. Third derivative is derivative of the second derivative. Use this expression without factorizing, non-factorizing expression. 120x cubed minus 180x squared minus 480x. For comfortable calculation, here we can take 60x out of the parentheses. 60x multiplied by 2x squared minus 3x and minus 8. Then continue. Then calculate the third derivative at first critical point. First critical point is 0. Open first point. Calculate f3 prime at 0. And for this substitute 0 instead of x. We obtain 0. It means we must find the next order derivative, that is the fourth derivative. F4 prime of x is the fourth derivative is the derivative of the third derivative. We have the non-factorizing expression of third order derivative and find the derivative of this expression. It is 360x squared. 360x squared minus 360x and minus 480. Then we can take 120 out of the brackets. 120 multiplied by 3x squared minus 3x minus 4. And again substitute 0 instead of x in the expression of the fourth order derivative. Fourth derivative at 0 is equal to 120 multiplied by 0 minus 4 is minus 480 isn't equal to 0. Here we must stop and look at the order of the first non-zero derivative, because this derivative is non-zero and its order is 4, and 4 is even number. According to our theory, x equals 0 isn't inflection point. X equals 0 isn't inflection point. The second point. Then calculate the third derivative at point at the second critical point is 4. F3 prime at 4. 3 prime at 4 is equal to, substitute 4 instead of x, 240 multiplied by 32 minus 12 minus 8, and it is equal to 240 multiplied by 12 isn't equals to 0. Here we must stop because the third derivative already isn't equal to 0, and then look at the order of this of this non-zero derivative. Order is equal to 3, and 3 is a odd number. It means here in this case we have the inflection point, and it means x is equal to 4 is the inflection point. X equals 4 is inflection point. Inflection point. And last point, then substitute calculate the third derivative at the point minus 2. F 3 prime at minus 2 is equal to substitute minus 2 instead of x in the factorizing expression of the third derivative. 60 multiplied by minus 2 is minus 120 multiplied by 32. It is, multiplied by 8 here, 8, because minus 2 squared is 4. 2 multiplied by 4 is 8 plus 6 minus 8 is equal to minus 720, and it isn't equal to 0. Here also we must stop because derivative already isn't equal to 0. Then look at the order of this derivative. Its order is 3, and 3 is odd number. It means in this case our function also has the inflection point. It means x equals minus 2 is inflection point. Thus our function has two inflection points, 4 and minus 2, but x is 0 isn't inflection point. Now rewrite your homework about the finding the inflection points with help of the higher derivatives. Write at home. Find the inflection points. Of the function. Function f of x is equal to 2x to 6 plus 3x to 5 plus 3x to 5 minus 30x to 4 minus 80x and plus 60 for with help of the higher derivatives. Higher derivatives. It is your homework. Then continue our lesson. Now let's go to the new topic named the integral calculus. The integral calculus. first we must learn the differentials, right? The differential, differential, differential of the function f of x is defined by the following formula. d f of x, it is a symbol of differential. D is equal to f prime of x multiplied by dx. It is formula for the finding the differential. It is differential of function. Differential of function. Then it is derivative of function. Differential is similar to derivative. Derivative of function. And it is differential of argument. Differential of argument. Consider the corresponding example. Find differential of, for example, sine x. d sine x is derivative of sine x multiplied by dx, and you know that the derivative of sine x is cosine x. That is the differential of sine x is cosine x multiplied by dx. Then continue. The basic concept of the integral calculus is the antiderivative or primitive. The antiderivative. Or primitive. Also we can use primitive. Antiderivative and primitive in Azeri it is iptidai функция. In Russian it is первообразная функция. The antiderivative f capital of x, the antiderivative of the given function f little of x is such a function f capital of x whose derivative will give the f little of x. That is, f capital prime of x is f little of x. For example, for the function cosine x, and its antiderivative is sine x, because derivative of sine x is cosine x. Therefore, one of antiderivatives of cosine x is simply sine x. If f capital of x is the antiderivative of the given function f little of x, then function f capital of x plus c, where c is the arbitrary constant value, arbitrary in Azeri it is arbitrary in Azeri it is ihtiyari. In Russian it is произвольный. Then function f capital of x plus c is also the antiderivative of the function f little of x, because its derivative will give the f little of x itself. That is f of x plus c prime is equal, you know that the derivative of sum is the sum of derivatives f of x prime plus c prime, f capital prime of x is f little of x, plus it is arbitrary constant, its derivative of constant is 0, plus 0 is equal to f of x. It means if some function, if the given function has at least one antiderivative, then this function has the infinite number of derivatives. And the union of all antiderivatives is named the indefinite integral. And indefinite integral is denoted in the following form. Integral of f little of x dx is equal to f capital of x plus c. It is indefinite integral. It is named indefinite integral. Indefinite integral in other it is Керемейный integral, in Russian неопределенный integral. Here f of x is named integrand. Integrand in other it is integral alты функция, in Russian подинтегральная функция. And f of x is one of antiderivatives, and c is arbitrary constant named the integral constant, and x here the integral variable. Then this formula is read as in the following form: integral of f of x dx is equal to f capital of x plus c. Then continue. Write the table of antiderivatives. The table of antiderivatives. Table of antiderivatives. The integral of 0 is arbitrary any constant. First, integral of 0 dx is c. 0 dx. Here integrand is 0 because derivative of c is 0. C is arbitrary constant. Is arbitrary constant. Arbitrary constant. Second, then find the integral of the power function. Power function in other it is кювет функциясы, in Russian степенная функция. Integral of x to n dx is equal to x to n plus 1 over n plus 1 plus c. Here n plus 1 isn't equal to 0. N plus 1 isn't equal to 0. That is, n isn't equal to minus 1. And then write the particular cases of this formula. 2a integral of dx, that is integral of 1 dx. 1 here the integrand is 1. Integrand is 1. And it is x plus c. That is integral dx is x plus c. Because derivative of x is 1. Second b, integral of x dx is x squared in half plus c, because derivative of x squared in half is x, simply x. Then 2c, integral of dx over x squared is equal to minus 1 over x plus c. We can prove this formula with help of the basic formula. Proof, we can write proof. Integral dx over x squared is equal to integral of x to minus 2 dx. Here n is minus 2. Then substitute minus 2 instead of n is this formula. X to minus 2 plus 1 over minus 2 plus 1 plus c equals x to minus 1 divided by minus 1 plus c, and it is equal to 1 minus 1 over x plus c. Then continue. Then write the fourth particular case of this formula, 2d. Integral of dx over square root of x is 2 square roots of x plus c. We can prove also this formula, proof or demonstration. Proof ispat, demonstration ispat in Russian доказательство. Rewrite the integrand and transform the integral to the standard form of the power function. Integral of dx over square root of x is equal to integral dx over x to 1 second equals integral of x to minus 1 second dx. Here n is equal to minus 1 second, and substitute minus 1 second instead of n in this expression. X to minus 1 second plus 1 divided by minus 1 second plus 1 plus c is equal to x to 1 second over 1 second plus c, and then we in final we will have 2x to 1 second plus c, or it is equal to 2 square root of x plus c. Then continue. Third formula, integral of cosine x dx is sine x plus c. Because sine x plus c prime is equal to sine x prime plus c prime is equal to cosine x plus 0 is equal to cosine x. Therefore, integral of cosine x dx is equal to sine x plus c. Then fourth formula, integral of sine x dx is equal to minus cosine x plus c. formula. Integral of dx over cosine squared x is equal to tangent x plus c, because derivative of tangent x is 1 over cosine x. Sixth formula, integral of dx over sine squared x is minus cotangent x plus c. Seventh formula, integral of general exponential function. Integral of a to x dx is equal to a to x over natural logarithm of a plus c. And 7a, if substitute e instead of a, then we will have integral of e to x dx is equal to, and you know that the natural logarithm of e is unit. Natural logarithm of e is unit, and therefore it is equal. It will be equal to e to x plus c. Then continue. Then continue, write the table of antiderivative, eighth point, integral dx over x is natural logarithm of modulus of x plus c. Why modulus x? Then now I will prove for you. Find derivative of natural logarithm of x, because prime is equal to, it is composite function, that is, it is a function of type natural logarithm of t prime. Natural logarithm of t prime is named logarithmic derivative, and it is equal to t prime over t. T prime over t equals 1 over x modulus of x prime over modulus x. Then remember the definition of modulus. Modulus of x is equal to plus x if x is positive, and minus x if x is negative. Use this here, this formula. Open system. It is plus x prime over plus x if x is positive, and minus x prime over minus x if x is negative. And continue. Equals derivative of x is 1, and derivative of minus x is minus 1. 1 over x if x is positive, and minus 1 over minus x if x is negative. Then continue. It is 1 over x if x is positive, and again 1 over x if x is negative. It means in all cases we obtain 1 over x. It is 1 over equals 1 over x. And ninth formula, integral of dx over square root of 1 minus x squared is equal to arcsine x prime, arcsine x plus c, or minus arcosine x plus c. And finally write the last formula. Tenth formula, integral of dx over 1 plus x squared is equal to arctangent x plus c, or minus arcotangent x plus c. And continue this topic next lesson. Now our lesson ended. Thank you for your attention. Goodbye, students.